Another academy. In this video, we are going to discuss about how to find resolved parts of a force and few problems based on this type. Okay, here what we are doing is a force F is going to be split up into two parts. One is along the horizontal direction, another one is along the vertical direction. Okay, after splitting the force into two parts, then we are going to find the resultant of any number of forces acting on a body. Okay, for doing any problem in mechanics, this resolved parts, finding the resolved parts is a very important concept, whether it is statics or dynamics. If you are very thorough with the concept of resolved parts, the problems will be very easy for you to complete. Okay, so let us do some problems based on the resolved parts of a force. Okay, see, suppose if I have a force F acting at a point O. Now you draw the usual horizontal and vertical line, that is x-axis and y-axis. Suppose if it makes an angle theta with the horizontal line, then this force, this is a single force, no? This single force can be split up into two parts. One is F cos theta along the horizontal direction, another one is F sin theta along the vertical direction. Okay, this theta is the same. Theta is the angle made by the force with the horizontal line only. Okay, but its horizontal component is cos of this angle, and when you consider the vertical component, the same theta has to be taken. Okay, not this angle. Okay, so for the force you are choosing only the angle which it makes with the horizontal line. With that angle we are writing horizontal component equal to F cos theta and vertical component equal to F sin theta. Okay, right, so these are called components of this force. That is nothing. Here we split this F into two parts. Okay, why do we do so? What is the purpose of doing like this? See, suppose if I have n number of forces acting on this body. Okay, I have P1, P2, P3, P4, etc. N number of forces are acting on this body at different angles with the horizontal. Okay, P1 is acting along this direction, P2 is acting along this, P3 is acting along. Then how can we combine all the forces and how can we find the resultant? In the previous video, I have given you two results on how to find the resultant. One is parallelogram of forces, another one is triangle of forces. In both the things, what you have studied, one is combining two forces acting at a point. Parallelogram law means what? Combining two forces acting at a point. In triangle of forces, you studied how to combine three forces, isn't it, acting at a point. But when you have n number of forces, polygon law of forces is also there, but still they all have some conditions to be satisfied. That means if you want to apply parallelogram of forces, the three forces must be able to represented in magnitude and direction by the sides of a triangle. Then only we can apply. And similarly for polygon law of forces, if you have any n number of forces acting on a body, it must be represented both in magnitude and direction by the sides of a polygon taken in that order. If it is not able to represent in that form, then what can we do? How can we find the resultant of all the forces? In those cases, this will be very helpful for us, that is finding the resolved parts. So what can we do in this type? So if I have n number of forces means I can find the angle each force makes with the horizontal line, no? So let me take P1, P2, P3, etc. Pn be the n forces, and let theta 1, theta 2, theta 3, etc. theta n be the angle made by them with the horizontal line. Okay, then each single force can be split up into two components, one along the horizontal and one along the vertical. So totally I will be having n number of components along the horizontal line and n number of components along the vertical line. Okay, so for finding the resultant, what should I do? I should find the algebraic sum of the horizontal components and algebraic sum of the vertical components. Okay, then from that I can find out the resultant easily. So this is a general way of doing problems. Both in statics and dynamics, you will be using the concept of resolution of forces. So this is very important for doing problems in mechanics. So let us proceed. Now, here I have given some of the examples of how to split a given force into horizontal and vertical components. See, this is the first one. Here I am having the force F, which makes an angle 60 degree with the horizontal line. Okay, so its horizontal component is f cos 60 and its vertical component will be what? F sin 60. Okay, simply in the place of cos, what you have to do? Replace it by sin. That's all. Okay, no other thing is required. Right? Next one. Next problem. See, this is a force which makes an angle 135 degree with my horizontal line. So what is the horizontal component? F cos 135 and vertical component is F sin 135. Okay, see, look at these two problems. I have given the force drawn from the origin towards outside, isn't it? So in mathematics, we usually take the outward direction as the positive direction, right? So here both the forces are taken in outward direction, so I have taken the angle as it is. There is no change I have made in both the problems. Okay, so directly we can write both the horizontal and vertical components. Next problem, you see here I have a force F which is coming inward, isn't it? Look at the direction here. Direction of the force is what? It is coming towards the origin and it makes an angle 30 degree. For these type of problem, you should not write it directly as F cos 30 and F sin 30. You should not write it like that. It is wrong. Okay. What you should do is, see, this is the line of action of the force, no? You extend this line of action. See, here I have extended, no? Actually, this dotted line, this is my force given in the question, but I have extended it. Now you look at this force. This is coming outward, no? Now this is outward. So from here, you measure the angle. So originally, what is the angle given here? 30 degree, no? If this is 30, this is straight line only, no? So this is 180 degree, na? So the total, how much angle will be there? 180 plus 30. So this force is making how much angle? 180 plus 30 with the horizontal. Can you understand? So if the force is given, look at the direction of the force. It has to be outwards from the origin. Then only you can take the angle as it is. If it is not outwards from the origin, make it as outward from the origin just by extending the line of action. It is nothing wrong in extending, because a force acting at a point can be considered as acting at any point on its line of action. That is, this is its line of action, no? So at any point I can consider. So there will be nothing wrong if you extend the line of action. Okay, just you extend it. Make sure it is coming outward from the origin. Then you measure the angle that will give you the horizontal and vertical components. So for this particular force, the horizontal component is what? F cos of 180 plus 30, and vertical component is what? F sin of 180 plus 30. Afterwards, you can do the manipulations. Okay, so these are the horizontal and vertical components. One more problem we'll see. See, look at this one. Here also I have given the force Fs in the inward direction, right? And it is making an angle of 160 degree as it is. Now you should not take it as it is. Now you extend its line of action towards this side. Along the direction of the force only you have to extend. So I have extended here, no? Now it is coming outward. Now look at the angle. This is 160 they have given. So this will be the total angle, no? So how much angle? So this straight line is 180. So already 160 is there. So along with this 180, how it will come? 180 plus 160. So the horizontal component is F cos of 180 plus 160 and vertical component is what? F sin of 180 plus 160. So from this we can find out the horizontal and vertical components. Understand? Okay. Then next one, theorem on resolved parts. This is what I have explained you in the beginning of the video. See, here I am having n number of forces, P1, P2, P3, etc., Pn, and each of these forces are making angle theta 1, theta 2, theta 3, etc., theta n with the horizontal. Then the horizontal component is given by P1 cos theta 1 plus P2 cos theta 2 plus etc. up to Pn cos theta n, and their vertical component is what? P1 sin theta 1 plus P2 sin theta 2 plus etc. Pn sin theta n. Right? See, if R is the resultant of all these n number of forces, that force R, let it make an angle theta with the horizontal. Okay, then R cos theta is equal to algebraic sum of the components of the forces, and R sin theta is equal to algebraic sum of the components of the forces along the vertical direction. Then R is given by square root of x square plus y square, and what is this theta? Angle made by the resultant with the horizontal line, and that is given by the formula theta equal to tan inverse of y by x. So in all the problems we are going to make use of this result only. This result is nothing but resolve all the given forces into two components. One is horizontal, another one is vertical. Find the sum of all the horizontal components, take it as capital X, and find all the sum of vertical components and take it as y. Okay, root of x square plus y square will give you the final resultant, and the angle made by the resultant with the horizontal line is given by theta equal to tan inverse of y by x. Okay, next one is condition of equilibrium. So in this particular case, how can you achieve equilibrium? How equilibrium is possible? Equilibrium means what? Resultant of all the forces together is 0. So here when will you get R equal to 0? When both x square and y square are equal to 0. Because square no, so they will be obviously positive numbers. So each one has to be 0 for making the resultant 0. So for getting equilibrium condition, you must have both the components equal to 0. If any one of them is non-zero, then equilibrium is not possible. Okay, right. Now let us do few problems based on the resolved parts. This is the first problem. Find the magnitude and direction of the resultant of three coplanar forces P, 2P, 3P acting at a point and inclined mutually at an angle of 120 degree. So I have three forces acting at a point. What is the angle between the forces? 120 mutually. That means if you take any two forces, angle between P and 2P, 120. Angle between 2P and 3P, 120. Angle between P and 3P. So everything, whatever pair you take, angle between them is equal to 120. Okay, this is what given. We want to find the resultant. Okay, whenever these types of problems are given, you take any one of the forces along the horizontal direction. That will give you a comfortable proceeding. Okay, so here I am going to consider this P is acting along my horizontal line x-axis. Okay, so I am assuming P is acting along this. Then what about 2P? 2P is making an angle 120 with P, no? So it will be on the second quadrant, isn't it? So this is my 2P, and how much angle it makes? It is making 120. Another one is what? 3P. So how much angle it makes? It makes again 120 with the 2P. So from 2P, how much angle you have to move? 120. So already this is at 120. So 120 plus 120 will be what? 240. So it is totally at an angle of 240 with the horizontal line. Why I am finding this 240? Because I want to find how much angle each force makes with the horizontal line. Okay, so this 120, 0 for P, right? Because I have taken P along x-axis, so it makes 0, angle 0 with x-axis, and the second force is making 120 and the third force is making 240. Okay, so what is the horizontal component x? Capital X equal to P cos 0, because it is along the x-axis, so cos 0 plus 2P cos 120 plus 3P cos 240. Okay, cos 0 is 1, so P plus, now I have to find these values, no? So let us split. 2P 120 can be written as 90 plus 30 plus 3P 240 can be written as 180 plus 60. Cos of 90 plus theta is minus sin theta, so minus sin 30 plus 3P into here cos of 180 plus theta is minus cos theta, right? So P plus 2P into sin of 30 is minus 1 by 2 plus 3P into minus 1 by 2. Okay, so if you take P by 2 outside, it will be what? 2 minus 2 minus 3. So x is equal to minus 3P by 2. Okay, next let us find the vertical component. For finding the vertical component, simply whatever you have here, no, replace all cos by sin. That's all. So P sin 0 plus 2P sin 120 plus 3P sin 240. Sin 0 is 0. So 2P sin of 90 plus 30 plus 3P sin of 180 plus 60. So this is what? Sin of 90 plus theta is cos theta. So 2P cos 30 and sin of 180 plus theta is minus sin theta. So minus 3P sin 60. So this is 2P into root 3 by 2 minus 3P into root 3 by 2. So if you take P root 3 by 2 outside, it will be what? 2 minus 3 will be minus 1. So the y component, that is the vertical component, is minus root 3 by 2 P. So what is my resultant? R, root of x square plus y square. So equal to root of 9p square by 4 plus here it will be what? Square of this will be 3 by 4 p square. Right? So if you add, I get it as 12p square by 4. So if you cancel 4, it will be 3p square. So it is square root of 3 into p. So this is my resultant. Next I want to find how much angle this resultant makes with the horizontal line. Because whenever you are saying about a force, you have to determine its direction also. So I am going to find its direction. That is its angle made by this resultant with the horizontal line. That is given by the formula y by x. What is this y? Vertical component minus root 3 by 2p by x is what? Minus 3p by 2. See, simply minus and minus I can cancel, but I am not cancelling. I am keeping it as it is. Let me tell you why. So you cancel the numbers. So finally what I have? Theta equal to tan inverse of 1 by root 3. Okay, 1 by root 3 means for which angle you will be getting? For 30 degree. But this minus I am keeping it as it is because this only will determine in which quadrant it will come. Okay, simply you can't write it as 30 degree because sine, cos, tan are all periodic functions, no? So you should clearly determine what is the angle. So it is not 30 degree. So both cos and sin, this is for sine term and this is for cos term. No, both sine and cos are negative, means in which quadrant? Third quadrant only. In third quadrant only, both cos and sine are negative. No, so this is third quadrant. Third quadrant means how will you write? 180 plus. So 180 plus. So pi plus tan inverse of 1 by root 3. This is how you have to proceed for finding the exact angle, right? So pi plus, that is 180 plus, this is 30, no? So pi plus 30 equal to what? 210. So the resultant will be making an angle of 210 with the horizontal line. Okay. Okay. Next problem. Forces P, 3P, root 3P and root 3P, 2 times repeated, act along straight lines OA, OB, OC and OD lying in a plane. Okay, if angle AOB 60, angle BOC 90, angle COD 120, find the magnitude and direction of the resultant. This is also like the previous problem. In previous problem, they have given 3 forces and the angle between the 3 forces. Here, they have given 4 forces and the angle between them. Okay, as usual, let me take the first force P along my horizontal line. So, this is going to be my OA. Okay, OA, no? OA. Right. What is the second force? 3P. It is acting along OB. And what is the angle AOB? 60 degree. So, OB is making angle 60 degree with OA, and along this OB, force 3P is acting. Okay, next one is angle BOC equal to 90 degree. So this is my BO, no? So take a line at 90 degree. Okay, this is my BOC, and along this line OC, root 3P is acting, right? Another one is angle COD equal to 120. COD. This is CO, no? So you have to D such a way that it is at angle what? 120. See, if this is 60 means this will be 30. If this is 90 means what? This is 60. If this is 60, this will be what? 30 degree only, no? So if this is 30, one more 90 you have to take, so that the entire angle will be 120. Okay, so here along this line you have to take root 3P. Okay, right. Then, so these are the 4 forces that I have expressed. But this is what given in the question. But for me, what should I do? I want to find the angle made by the forces with the horizontal line, isn't it? For P, it's okay, it is 0 degree. For 3P, it's okay, it is 60 degree. But for these 2 forces, I have to find the angle made by them with the horizontal line. So how will you find? This is 90 plus this is 60 means what? This will be 90 plus 60. Here I have written. This will be what? Totally 90 plus 60. 90 plus 60. And what about this one? This will be 120 plus 60. Okay, 120 plus 60 will be what? So 120, not 120 plus 60. 120 plus 90 plus 60. So totally what? 270. Right? That is, it is along the negative y-axis, no? So it is 270. So for any problem, you have to find what? The angle made by the forces with the horizontal line. So I have written here, P is making 0 degree, 3P is making 60, root 3P is making 90 plus 60, and root 3P is again making 270. So let me write the horizontal and vertical components. X equal to P cos 0 plus 3P cos 60 plus root 3P cos of 90 plus 60 plus root 3P cos 270. Okay, right? So P cos 0, P here 3P into 1 by 2. This is root 3P into cos of 90 plus 60 is minus sin theta. So minus sin 60 means what? Minus root 3 by 2. Here cos 270, that is along this line. It's equal to cos is 0, no? So 0. So what do you have? P plus 3P by 2 minus 3P by 2. So simply it is what? P. So the horizontal component is equal to P. Next, vertical component. The same thing, that you have to replace all cos function by sin. So P sin 0 plus 3P sin 60 plus root 3 sin 90 plus 60 plus root 3P sin 270. Sin 0, 0. Sin 60 is what? Root 3 by 2 plus, here sin of 90 plus theta is cos theta. So cos 60 is 1 by 2 plus root 3 into sin of 270 is minus 1. Okay. So what will you have? Root 3 by 2P, if you take outside, what will you get? 3 plus here 1. Here it is what? No, by 2 is not there, no, so it will be minus 2. So what I have? Root 3P. So horizontal component is P, vertical component is root 3P. So the resultant R equal to square root of x square plus y square equal to P square plus 3P square equal to 4P square. So R equal to 2P. And what is the angle made by the resultant with the horizontal line? Tan theta equal to y by x equal to root 3P by P equal to root 3. So here both are positive, no? So no need to check the quadrant. Directly you can write. So both are positive means it will be in the first quadrant only. So root 3 means what? It is 60 degree. So this is the angle made by the resultant with the horizontal line. Okay. Next problem. three forces P, Q, R act on a particle in one plane. The angle between R and Q, P and R, and P and Q being alpha, beta, gamma, respectively. Show that the resultant is this. Okay, so as usual, let me take first force P along the horizontal line, another force Q. So what is the angle between P and Q? This is the third angle, gamma. So let me draw one line at an angle gamma and make it as force Q. Okay, another force is R. So how much angle R makes with P? P and R. What is that? Beta. So I am drawing this R and it is making an angle beta with P. Okay, one more angle is given alpha, which is the angle between R and Q. R and Q angle alpha, but it is not required for me for finding the components. So I am not going to touch this alpha. Only with this gamma and beta I am going to write. So horizontal component P cos 0 plus Q cos gamma plus R cos beta. So this is P plus Q cos gamma plus R cos beta. And what about Y vertical component? Replace all cos by sin. So P sin 0 plus Q sin gamma plus R sin beta equal to, this is 0 no, so Q sin gamma plus R sin beta. So the resultant R equal to square root of x square plus y square equal to, this is like a plus b plus c the whole square no. So a square plus b square plus c square plus 2ab plus 2bc plus 2ac plus next y square. This is like a plus b the whole square. So a square plus b square plus 2ab. Right? Now let me write p square. Here you see q square cos square gamma. Here q square sin square gamma no. So q square into sin square gamma plus cos square gamma equal to 1. So it is what? Simply q square. And similarly r square into cos square beta plus sin square beta. Simply r square. Okay. Plus remaining terms let me write 2pq cos gamma, 2pr cos beta. Then these two are same terms of, no, different terms. 2qr is a common factor. Take it outside. It will be cos gamma cos beta plus sin gamma sin beta. This is looking like cos A cos B plus sin A sin B. This is nothing but cos of A minus B formula. So I am writing it as cos of beta minus gamma. But look at the diagram. What is this beta minus gamma? That is your alpha. Okay, so instead of this beta minus gamma, I can replace it by alpha. So this is the resultant which we want to derive. Right? Okay. Next problem. Forces P, 2P, 3P, 4P and 2 root P act at a point in directions of AB, BC, CD and CD, DA and AC of a square ABCD. Show that they are in equilibrium. See, they have given 5 forces. They are acting along a square. So let me draw a square ABCD. Right? Along AB, force P. Along BC, 2P. Along CD, mark the direction correctly, 3P. Along DA, what? 4P. Then along AC, this is AC diagonal, no, 2 root 2P. We want to find the resultant. So let me draw it in the line. So as usual, I am going to take the first force along the horizontal line P. Okay. Now next, second force 2P is there, no. So this is along the upward vertical, no. So this is my 2P. Okay. The next 3P, you see it is this is my horizontal line, positive horizontal line. So this is coming in the opposite direction, no. So here in the negative x-axis, you have to mark this 3P. Okay. And similarly, look at this 4P. This is along my positive y, this is along my negative y. So this is my 4P. And see this one, 2 root 2P. Diagonal means what? In a square, the angle between the sides is 90 and angle between the diagonal and the side is what? 45 degree, no? So at 45 degree, you have to mark 2 root 2P. Can you understand? Right. So I have written the angles here. P is making angle 0, 2P angle 90, 3P is making angle 180, 4P is making angle 270 and 2 root 2P is making angle 45. Now you find the components. X equal to P cos 0 plus 2P cos 90 plus 3P cos 180 plus 4P cos 270 plus 2 root 2P cos 45. So P cos 90 is 0 and cos 270 is also 0. And cos 180 is what? Minus 1. So minus 3P plus 2 root 2P into 1 by root 2. So minus 2P plus 2P 0. So the horizontal component is 0. Next vertical component. Replace all cos by sin. So P sin 0 plus 2P sin 90 plus 3P sin 180 plus 4P sin 270 plus 2 root 2P sin 45. Sin 0 and sin 270 are 0. Okay, so no need to write. 2P sin 90 is 1. Sin 180 is what? Minus 1. So 4P into, sin 180 is 0. Sin 270 is minus 1. Sorry. So sin 270 is minus 1. So 4P into minus 1 plus 2 root 2 into 1 by root 2. So we get 0. Therefore, the vertical component is also 0. Both horizontal and vertical components are 0. Hence, the forces are in equilibrium. Okay, next, last problem. See, forces acting at a point are represented in magnitude and direction by AB, 2BC, 2CD, DA and DB, where ABCD is a square. This is also like the previous problem only, but in the previous problem, the forces are acting along the sides but not represented in magnitude. Okay, the magnitudes are different. Directions are only along the square. But here both magnitude and directions are given in terms of the sides of the square. So here no need to make use of the resolved parts. I can make use of polygon of forces itself. Even by using result parts also you can do, but by using polygon law itself you can get the result in one or two lines. Okay, now you add all the things, AB plus 2BC plus 2CD plus DA plus DB. No, see, let me take 1 BC and 1 CD here. So what will I have? AB plus 1 BC plus 1 CD plus 1 DA. What is this? AB plus BC plus CD plus DA. So these are the forces represented in magnitude and direction by the sides of a square taken in order. So by using polygon of forces, the value of this is equal to 0. Okay. Next, I have taken only one BC here. No, so one more BC is there that I have written, and from this CD one more CD is there that you should write it here. Plus one more DB is there. No, plus DB. But what is BC plus CD? Use triangle of forces. BC plus CD is nothing but BD, right? Plus DB. BD plus DB, two equal and opposite forces. So their resultant is also equal to 0. So here I didn't make use of resolved parts. I have used only polygon of forces and triangle of forces. From that itself I have obtained the result, the forces on equilibrium. Okay, this can also be done by using the theorem on resolved parts, but it's not necessary. Just by simply adding the values you can get the result. Okay, that's all. Thank you.